we will talk about an ORM. So, do you know what is ORM? Maybe someone can tell me. Okay, so I find the greatest picture that describes an ORM. So ORM, it's a bridge that connects our database, our SQL statements with our Python code. So for now, in project 7, you worked with raw SQL, with database, with dbeaver, but how to implement it in our Python code? Do you have any ideas?
Use with ORM, link our database, our local SQL thing with our Python code.
Yeah, right. We need an ORM, basically. So we will talk about an ORM SQLAlchemy. It's an industry standard for ORM in Python frameworks. But let's talk about ORMs. What is this? So let's imagine that our SQL query is a cookie. And we can create cookie by ourselves. We can mix all the ingredients, form cookies, turn on oven, like place cookies in the oven, wait sometimes and take it off, turn off oven, wait until everything will be cool, and eat our cookies. So imagine that when you're creating cooking by yourself, you're using a raw SQL query. And when you're using a ORM, you have a factory that creates a cookies. You don't need to mix anything. You don't need to do anything. You just have an interface, for example, a computer on your factory, where you just given some numbers like a temperature, amount of cookies, maybe some other parameters, and everything working under the hood without your direct control, and you have those cookies cooking constantly. So here, a little spoiler, you already can see the how our SQL query looks in ORM. Basically, it's functions, Python functions, and this gives us, it makes our queries easier to understand, to write, and etc. So basically, ORM we make automatization of for our SQL queries using ORM. So what's the pros and cons of ORM? Most obvious is a clean and short code. You can see this is the same query in raw SQL and in ORM syntax. Then cross-database compatibility. Different databases have some differences in querying. For example, MySQL, Postgres, or SQLite have some small differences. ORM builds every query under the hood, so you have the same syntax in Python for every query, but ORM knows what database type you're using and adjust your query to build an actual query for this database. Prevent SQL injection. So ORM gives us another level of security that we, for example, if we are not very experienced users of SQL, we may have an SQL injection. Do you know what a SQL injection is? So basically, for example, in SQL, we can use some parameters. For example, if you have a where statement, we have some parameter. For example, we have this parameter from our user. So some user filled some form, submitted it, we had this number or some value, and we performing our SQL query. But what if this user typed some other SQL query in this parameter, and we are running our SQL query with this SQL query that our user injected? So in this SQL query of this user may be something like drop database, and it will be executed, and on our server we will have drop database without, maybe we don't even have some recovery tools, so we will be in a bad situation. So ORM under the hood manages all those SQL injections, and we don't need to think about them. And reusable models, we'll talk about this later. But also we have cons. If we have a big query, for example, it will be slower with ORM, and this makes sense because this query building under the hood with ORM by algorithm, and in some situations this algorithm could be not so optimized as we want. So for sometimes we can use a raw SQL just in our Python code. It's also okay, and ORM gives this possibility to create queries not using this fancy declarative style, but using raw SQL. And sometimes feels like a black box, but I think FastAPI may feel like black box, or anything may feel like black box. I don't think it's a real cons, but it's a cons. What alternatives do we have? We can use a raw SQL. We can like write, select all this stuff, and pass it as a string in our Python code. It's possible. And also we can use a query builder. This is some software that helps you create complex queries. So let's talk about SQLAlchemy. What is SQLAlchemy? It's a library for Python that manages SQL, and this is, I think, most advanced ORM for Python for now. So I have an example for you. I have such a database. We have users. One user have many posts. One user have one user profile. In user profile, we are storing additional information about users. Also, posts have tags, and this is many-to-many connection. So we have associatable post tags. We will use this database for all the examples that you will see during this part. So in SQLAlchemy, we have three main concepts that you need to understand to work with SQLAlchemy. First of all, it's an engine. This is our entry point to our database. So we have our database, we have our server, and in engine we specifying how to connect, how our server can connect to database, and this is our gateway. Declarative models. Declarative models is a way to map our tables in our database with classes in Python that will represent our tables in database. So we will have classes that represent our tables, and we can work with those classes as with any other classes in Python. We will create an objects, and those objects will be an actual rows from our database. And sessions. Sessions, I think, is the most difficult concept, but I think you will like get it. So sessions is a workspace in ORM to work with a database. I will tell you more about sessions when we will read this part. So let's start from engine. As I said, is our first point of contact with the database is our gateway. So here you can see that basically we have in SQLAlchemy. So I need to tell first of all how can we get SQLAlchemy. All we need is just in our vent write pip install SQLAlchemy, and we have SQLAlchemy like we have FastAPI, Unicorn, and I don't know what else we have right now, but all we need is just type pip install SQLAlchemy, and we will be able to use all those functions, methods, and functions, classes, etc. So in SQLAlchemy, you can see we have method create engine, and basically create engine creates an object that we will use to work with database. But I need to say that engine, this is not the object that will help us to make some changes in database. We will make any change in database using sessions, but engine is our object, is a gateway or for connection with database. So you can see create engine have two parameters, data source name and, for example, echo equals true. Echo equals true makes all our operations in database those operations will be printed in console. It's easier for debugging. What is data source name? You can see it have such a notation. So we have dialect plus driver. Dialect is a type of our database. In this situation is Postgres. Driver is a library that helps using this database. Then we have our user and password. So when you have created your database, you have, for example, default user, super admin, or admin, or I don't know, and you have a password. So for your database, you can create other user with a password, and here you need to pass this information. In my situation, it's my admin and password like this. Then we have asterisk, and then we need to pass host, port, and database name. In my situation, you can see it's host, it's localhost, port is 5432, and database name, my Instagram, because it's literally my Instagram. And I have predefined code for this. So here you can see that I have already created this engine. You can see my project structure. I have database file in which I manage engine, and we will talk about this later. So for now, all you need is create the engine. This is the simplest concept from all of them. So what next? Yeah.
The thing after my admin is the password.
Yeah, my admin. Then I have problem with these symbols, guys. Semicolons, right? No. Double colon.
I forgot those.
Vertical to column combination of symbols. Yeah, and then password. We can move on?
Yeah.
So next, declarative models. Basically, we have a mirror. So we have our table in database, and also we can create the representation of this table in our Python code. So our declarative models is like a mirror image of our tables. First of all, to create a declarative model, you need to create a base class. You need to create base class and what's the word? Наследовать. Inherit a declarative base from SQLAlchemy. This base class then will be then when you will create all of your models, you will inherit this base, and you need to do this because base is a meta class that will help us to map our code to existing database table under the hood. So let's talk about our model structure. For example, for our user table, first of all, we have resource name, table name. Here we are writing our table name. We need this to map this, so ORM could map this model, this class, to actual table. Then, as you can see, all the fields from our table, we recreating it as a fields in our class. And you can see that we have a mapped type that shows us that this field is a mapped field from our table. Mapped also we can find mapped in SQL library, and you can see that we can predefine our mapped column with some rules. For example, our ID is a primary key. How in our declarative model we can show that this is a primary key? We have function mapped column, also provided by SQLAlchemy, in which we can show, we have parameter, we can show that this is a primary key. Primary key equals true. The name. Name is a string, a varchar in SQL terms, and we want to have some restrictions, and also we can use mapped column to do this. We can say that this is a string with only a maximum amount of 100 symbols, and it's not nullable. Any questions here? Yeah, because when we're using mapped, basically it means that we can write here mapped column and empty space. So under the hood, it will map our mapped with this field. But if we have some additional properties, we need to specify it in mapped column. Yeah. So next, relationships. How can we specify relationships in SQLAlchemy? We're creating a bidirectional connection. So let's see our database structure. So we have users and we have posts. One user have many posts. As you can see, in posts we have a foreign key to the user ID. And what we have in this example with relationships. Our user have posts. And we can see that this is mapped a list of posts. And we write post like this, like string, but we're writing here a name of our post class. So we're showing that one user have many posts. And we have a function relationship where we specify field backpopulates and then user. And what is a user? User, it's a name of this relationship in class post. So in post, we have field user. And as you can see, in user, we specified connection with posts here. And we're saying that in post, this relationship called user. And we have user in post. We mapped it to user because one post have only one user. User have many posts, but every post have only one user that created it. And also we're using relationship to specify that this is a relationship, not a mapped field. And back populates posts because in user we have field posts. Does it make sense, guys?
Yeah, what?
With a list.
Maybe if this means the other one. And the first one question, can we map one-to-many direction? What?
Yeah, just use another direction.
So we need to have like an opposite direction in our declaration, or can we put the word list into the relationship?
Yeah, look, it's very important what structure we have actually in database, because when we creating a declarative models, we just representing an actual connection, actual structure of our database. So if we will have such a structure where one post have many users, for example, and here you will have post will have a primary key ID, and users will have post ID, a foreign key. In this situation, yeah, we will just in declaration will say post mapped to list of user and user mapped to post. Maxim. Okay. Other questions?
These are things that it's like other whether it's some activities like possibly I just still the white those that
We can ask SQLAlchemy developers, but Dima, you know why it's called backpopulate? Just have it as a fact. But also we have use list parameter in relationship, and we use it when we have one-to-one connection. So here you can see that user and profile have one-to-one connection, and you can see that we inside the user model, user class, we have field profile mapped to profile. And this is a relationship. Backpopulates user, because in profile we have relationship user, and use list false, because it's one-to-one. Because SQLAlchemy very smart, and it knows that relationships works in such a way that if we have many on one side, we have one on other side. We can have many-to-many directly written in the declaration. For many-to-many, we need to create an associate table. So SQLAlchemy knows that if we have many lists on this side, it means that we don't need a list on this side. But for situations when we have one-to-one, we need to specify that use list false, so SQLAlchemy will not expect us to have a list on one of the sides, to not have a many-to-one, one-to-many, but have one-to-one. Yeah. And also here in this example, you can see that, for example, our ID field mapped column primary key and also auto increment, for example. It's also a field that we can specify in mapped column. Okay, so let's move on. One-to-many. So I showed you relationship, one-to-one, one-to-many, many-to-one. I already talked about this, but we can like talk about this one more time. So yeah, basically we have a mapped list, post, and user. This is the same example. And how to create many-to-many. So here you can see that we have posts and text, and the connection between posts and text many-to-many. So we have to, for this we need to create an associate table. Pretty basic technique, but to not create a model, not create a class for associate table, because we don't need actually an associate table. It is just an instrument. We can define table in our ORM just like this. So we can use a table object. We will pass our associate table name. We will pass our base metadata, because all of our models that we creating declaratively or like this, we need to pass base, and then we defining two of our columns. We writing its name, and we saying that this is a foreign key or post ID, for example, of text ID, posts and text, the names of those columns, and saying that this is a primary keys also. And inside post and tag, you can see that inside post we have tags. It's mapped list tag relationship, but we have also parameter secondary, and inside this secondary we passing an object of our post tags, our associate table. So if we want create many-to-many relationship, we need to create an associate table, and inside declaration we just need to specify this secondary table, this associate table like this, and everything else the same. And SQLAlchemy will know that tags and posts, it's a many-to-many connection. Makes sense? And also, let's talk about cascade. You know what is cascade?
When first you're a domino, so I guess use the context of database cascade usually in the context of relation when we delete something, or it's like children or connected tables also get fixed. The relation target.
Yes, thank you, Maxim. So basically this is it. Inside relationship, we also can specify cascade parameter and specify what will happen when, for example, we will delete or save this object. So, for example, if we will specify delete orphan, when our user will be deleted, also automatically will be deleted all of its posts. So delete orphan means that in our system we will not tolerate any posts that have a foreign key of user that actually don't exist anymore in our system. Yeah, and I think this is it about models. Let's see how it looks in real code. So here you can see I specified the base class, I inherited it from the declarative base. Declarative base I imported from SQLAlchemy ORM. We can see that we have SQLAlchemy and also SQLAlchemy.orm. It's like a directory inside SQLAlchemy library. And you can see that some things we importing from SQLAlchemy, but some from an ORM folder of SQLAlchemy. So declarative base we imported from there. We created this base, and then we just created our model, our class that represent our table in database. Here you can see table name users, then an ID. It's a mapped int because our ID is an int, and here you can see that I specified that this is a primary key and it's an auto incremented. And also we have name, also mapped but to the string, and this name have restriction in 50 string symbols. Also we have two relationships, posts. You can see that it's mapped to a list of posts, so one user have a list of posts and back populates to user, because in posts we have relationships that called next or called user, and also we have relationship with profile one-to-one. Here you can see user list false. Also in profile you can see that we have also table name, also mapped, but you can see that profile and user have the same ID. So some of you had such thing in your projects, in project 7. User and profile. You can see that ID of user is a primary key, and for ID of a profile also primary key, but ID of profile it's also a foreign key. So it's possible, but to do this we need to specify in profile that ID of profile it's a primary key, but it's also a foreign key of user's ID. So when we specify a foreign key in our fields, we need to specify that it's a foreign key and specify the table and the field in which to which we connecting this primary key and everything, and we do this in a mapped column. The same with the bio, mapped column as a name is user. And here you can see relationship with a user, and you can see the backpopulates profile, and inside user we have this relationship profile. The same with the posts. So let's move on. Any questions here? Okay. Guys online, I don't know, maybe I don't hear you, maybe I have some problems with the speakers. Are you here, like, is everything clear?
Yes, we just don't talk.
Okay, thank you. So let's move on.
Yeah.
Thank you. Let's move on. Sessions. Oh, it's a hard one, difficult one. So what is sessions? Session is a temporary workspace that we use to work with database. So what's the interesting part about SQLAlchemy? It gives us sessions that give us opportunity not mess up with our database, because when we're creating session, we can do potentially any changes with this database, not actually creating those changes in a real database. And if we want to save changes that we did to our database, we use a commit method. So we're creating so here you can see my beautiful diagram. We open the session. Open a session means we're creating an object of class session, basically. Then in this object, we have functions that you saw already in some of previous slides, first slides. We can do some query, select, insert, delete, anything. But all of those changes doesn't matter. We did those changes only inside the sandbox that our ORM SQLAlchemy gave us. And only when we saving those changes going in a real database. But also we have function rollback that will roll back those changes. If, for example, something happened, some error popped up or something like this. And then we are closing the session. And you can see that then we repeating. So what does it mean? We are opening session, do some work, and closing session every time when we need to do some transaction, some logical operation with database. Because sometimes one logical operation with database, it's not only one query. It's, for example, two queries. For example, we need, in one logical operation, we need to add a post to a user and change something in user that will reflect that he have posted this post. For example, we have a streak of posts for user. If user posts every day, he achieves some badge, some, I don't know, achievement inside our system. So, for example, user posted post, and we are opening the session. We creating this session, like inserting it in our database. Then we check if he posted yesterday. If yes, we do some changes in the user. Then, if everything okay, we don't have any errors, we commit those changes and we close in the session. This is one transaction. This is one logical operation with database. And for this, we are opening session. So basically, you can imagine that you already have those endpoints, right, in your framework, like post, get, like this. And basically, I think all of those endpoints will use in some way your database. If you have a get user, you will ask this user from database. If you have save user, you will save this user to database. So basically, you will open session for every endpoint. For when your user, reaching your endpoint, every time you will open session, do some work, commit changes, and close the session. So this is how sessions work. But you can see very strange code. We have session local equals session maker function. So let's start from after commit, auto flush, and bind engine. After commit means that if after commit false, we need to call commit function when we stopped doing some changes and want to save those changes. If after commit will be true, our changes that we are doing with database will be instantly updated with the real database. After flush, the same as after commit, but I will tell you what is flush next. And we need to bind engine. So basically, we created our engine, our gateway with database, and then we need to build our session to the engine. This is pretty logical. Session needs to know with which database to work. But what is session local? Why session maker function equals to type? So you worked already with stuff like this during our third, fourth, and fifth lectures when we created our framework. Basically, maybe someone will tell me what's happening here. What does mean session local equals session maker function? What is instance of session maker? What session maker function return when it completed this function? A type, a session local. But session local is a callable. And in next slides, you will see that one moment. Sorry. You will see. Okay, I will tell you about this later. But session local is a callable. So you remember that everything can be callable in a Python. Callable is like a button that we can press at some point, and even class can be callable if it have a magic method call, right? So session local, you can imagine that session local is a callable that when we call it returns us a session object. So to work with our database, we need a session object. To have this session object with predefined parameters, like for example, engine, after flush, after commit, and many hidden under the hood, we use such architectural approach as a factory. Factory, it's a module, an entity that creates an object. So in this situation, session maker, it's our factory that creates a callables that when you call them, gives you a session. Is it clear, guys? Yeah, so basically, you have your session local. When you will call your session local, and how can you call callable? Do you remember? What one way to call, no, maybe not one, but a way to call callable in Python? Yes. So we have session local. It's a callable. Without parentheses, it's just a callable. But when we will add at some point columns, we will call this callable, and we will have as a return value a session object that we need to do some work, commit changes, close session. So we will have this session. We will have this object session. So it's pretty abstract, and I think you don't need this deep knowledge in like how session maker works under the hood, but you have a basic like overview knowledge. So next, let's talk about methods. So what we have? We have commit and rollback. Already talked about commit. You can see that, for example, we can create our user. User is our model, so we can see that we're creating an object of our declarative model, a representation of our actual table. And also we have add function. This is like an insert, but we not changing our database until we will call a commit function. But you can see that when we create a user, we're saying that name is none. But as you can remember, name, okay, here it's maybe null, but imagine that name is not nullable. Nullable equals false. And in this situation, when we will commit, our SQL will give us an error, and accept will be triggered, and we will run our rollback function. So commit and rollback, I talked about this previously. Commit saves our changes, rollback undo all the changes that we did in one session. So sessions are pretty useful because they create boundaries for your operations, and you will not be able to mess up big time.
Yeah.
Yes. Yes. So next, the flush. Flush makes us to push changes to database before committing. So for example, and this is a great example because we have our user, we added this user, we need our user ID. For example, we need our user ID for other operation. We need to create user, and then we need to use this user as a foreign key for some other operation. For example, in this situation, we need to have our user ID first. But if our user ID auto-incremented, we can't have it until we will commit our changes. For such operations, we have a flush. So we can add user, we can flush it, and then inside our user model already we will have an ID that will be generated after incremented, and then we can use this user ID, and then we can commit all of our changes. Makes sense?
Mm.
You will work with this during your assignment. You will be able to play with this. So, how to use sessions? You can see an example of your root. So, what this root does? Who can tell me? Yeah, this is a post method to create a user. So we have user create. What is user create? What do you think?
And separate node.
No, base model is a user. But user create, maybe other ideas.
But that's the model that we can solve like anything.
Mm-hmm.
Like the progress would have three. So that's one side plus
In other words, this is
like
almost
correct.
called. Dima told you about this. This is called Pydantic schema. Right? Yeah, maybe you forgot, but we have schemas, Pydantic schemas. For example, and this is how, this is what we will have from a user that trying to create user. So user create, for example, this post method, when we performing our post method, we sending something to server. And in this situation, we will send information based on which we will create our user in database. And in this situation, we have user create. But what is user create? User create is a schema like this. But what does it mean? This means that let's run this code. So post user try it out. This is a JSON, but in our code we have a model and schema that represented this JSON that we have from our user. This is a little recap of Dima's lecture. So what we have here, we have our Pydantic schema user create that we have from our user. Then we are creating a session. As I said, when you call session local, you have as a return value session object. We saving the session object in database variable. Then we're creating our user. We are using user declarative model. As you can see, we defining that name is a username. User is our Pydantic schema. Then we add our user in session. Then we commit. Then we refresh. Refresh means that we updating our database user, because updating this object. Because when we committed our user, we added after incremented ID. To have this ID, we need to refresh this object. Then we close and returning our database user. But you can see that our response model is user out. What is user out? User out, it's also Pydantic model that have an ID. Because we added an ID, it's automatically added by after incrementation. But how FastAPI knows how to map our user model to our user out schema automatically. Yeah, so we can do this like this, but it's wrong. Cause why? Why it's wrong? What you don't see here? Maybe someone in the first line already said this word when I wanted to hear other words. What we need here? Decorator. You said decorator. Okay, not decorator, but the same first letter. Dependency injection, right? Because this is a great example how we can use dependency injection. As you can see, what happening here. Let's see our method. We don't open session right in our root. We don't close it here. We use our session. We're using depends for this. So you can see that we want a DB variable with a type session. This is session of SQLAlchemy that equals depends getDB. GetDB, this is a method in which we opening session, then yielding this session, and finally closing. What's the difference between return and yield? Maxim, what is the difference between yield and return?
No idea.
So when we're yielding when we're returning something, it means that this function is done. Return equals the end of execution of this function. But yield means that we will wait when other operation will be done. So in this situation, we will yield our session until this makes sense in other function, and only then we will close it. So we automated this process. We have this function that we pass into depends to here, and depends knows when it's time to stop this yield process and do this finally process. So depends do this under the hood. So what we have in the result? We don't need to open session every time in every route. We save, like for the project where we may have 500 routes like this post users, we will save many thousands lines of code, because we don't need to open session, we don't need to close it. We don't afraid that we will forget to close session, because if we will forget close session, the session will be in our memory all the time, and at some point our server may crash, for example, if there are many sessions not closed. So we create a situation where we save from such things. So I have another analogy for you. I used Dima's previous analogy with coffee, but here you can see. So we have a session. Session is our cup of coffee. And we have method session maker. Session maker is a factory of sessions. And basically it's a coffee machine, because session maker makes us a coffees. And depends get DB is our barista. Why? Because in this situation, we are doing coffee by ourselves. We are using coffee machine, we creating coffee, and after we drunk coffee, we cleaning the mug. We are closing this session. But in this situation, our depends get DB open session for us, making coffee, yielding it to us, because I have an analogy that when you take coffee with you in a plastic cup or paper cup, you like barista returning this coffee using return operation. But when you drinking coffee in a cafe, it's yield, because barista waiting when you will done with your coffee to take this mug and clean it. And clean mug is like session close. So analogy like this, you can appreciate it. I tried very much. So building queries. Let's see this example one more time. So what we have in our database file, we have an engine, we have we have an engine, we have session local, that this callable that created with session maker, and we have this getDB function that we will use with our depends method. And inside main, we have many methods that uses this getDB. For example, create user. For creating user, we need to create an object of our declarative model. Then we need to add this model. Then commit, refresh, done. Get users. Here we will use our select method. So let's talk about this. How to perform actual queries. So as you can see, it's pretty similar to how we do this with this raw SQL, but we are using a Python method for this. So the main method, it's a select, and select statement for select statement, we have select method. When we created our select statement, we can use execute we can use two methods, execute or scalar, to run this query. So, for example, if we want to select in this presentation, I will share this presentation with you. You have a query with a row SQL and how it will look using SQLAlchemy. So here, for example, if you have specific columns, you specify you want an ID and name from users. You inside your select, you saying that you want those columns, and then you executing this. If you want only first row, so you have a limit 1, you use a method first, for example. If you want to use where, you to your select adding method like with this chain method, you adding where, and you have a statement inside where. So it's pretty easy and very similar to actual SQL, but using Python methods. Also, if you have and, you adding those and statements with a comma. If you have like, you have inside your mapped field already predefined, you have like function operator. Then joins the same. If you have add an inner join, you adding it like this. If you have if you want add left join, you can add is outer true. If you want to add multi joins, it work like this. You just adding those joins. So those statements looks pretty much like actual row SQL with some minor differences. Aggregation, the same here. We have grow by. Also, we can set label. It's a representation of S parameter. Yeah, so like this. A count, we have func count inside SQLAlchemy. So everything works pretty similar. Same with sorting. Accident, dissident, we can see that order by, ask, desk. And debugging. The same, to run explain, you need to run this code. So you can see this explain statement. You need to add it as a basically row SQL, but it will give you the same results as explain when you run in a row SQL.
What? To speaking, but very much 5. Okay.
Yeah, and this is it. We have class assignment, but I can show you how it will work. It will look in your assignment. So, for example, we want to create user max. We will create our user max. We have some error. Okay, I killed my database. So my database is not running right now. Okay, but I think you have an idea. Yeah, I will share this code with you. So basically what we have here, to get users, we select user, then run scalar and return the results. And response model is a list of user out. User out, you already saw them. This is user out. It's have an ID and name. To delete user, Also, we have delete function inside our session. To create a post, first of all, we need to get our user with specific user ID. Then we need to create an object of our declarative model with title and user ID that with user ID of user who created this post. Then add, commit, refresh, return this.